In this video, we're going to do a quick review of dilations. Now, a dilation is a transformation that preserves the shape of a geometric figure, but not necessarily the size. So I can reduce or enlarge a figure using a dilation. So the notation in the example that we use for this is, given the triangle QRS, I want to dilate it by a magnitude of 2 from the origin. And so the notation for this would be a capital D for dilation, a subscript, which the subscript would be the coordinate that I am dilating, or the point of dilation. So in this case, the origin, or 0, 0, which we can denote either using 0, 0, or we can denote with a O for origin. And then next to it, the magnitude at which I'm enlarging or reducing a figure. So if I graph QRS, and by dilating each of these coordinates by 2, I'm essentially multiplying by that scale factor of 2, creating Q prime, R prime, S prime given, and you can see by the graph that it is an enlargement, and it looks double in size from QRS, the pre-image. So that's making a dilation on the coordinate plane. So now let's think about a couple of different things with the dilation. The perimeter and area. So the perimeter of a dilated figure is enlarged or reduced by the same scale factor, which makes sense. If I have a perimeter, the perimeter is the sum of all the sides of a triangle, or any figure for that matter. Well, if I increase all the sides by the same magnitude and then sum that up, it's going to be the same scale factor as the side lengths. So the sums would be the same scale factor, and we'll look at an example. So then the area. Now the area is a bit different because the area is the ratio of the lengths squared. So let's look at an example of this. So the perimeter of triangle ABC is 24 inches. The area is 60. If dilated by magnitude of 3, find the perimeter and the area. So the perimeter is the easy one. That is just, as we know, increasing by the same scale factor. So I'm multiplying by the magnitude, which would give me a perimeter of 72 inches. Now the area is a bit different. The area, we know, is a ratio of the lengths. And so if we could assume, and not so much assuming, but if I'm dilating by a magnitude of 3, the pre-image side could be 1, which would then make the image side 3, because 1 times 3 would be 3. So this shows you that all the side lengths have a ratio of a 1 to 3. And I use 1 as the example to kind of develop this ratio. You could do 6 to 18, which would reduce down to 1/3. So it's the ratio of what I'm enlarging or reducing by. And then for area, it's squared. So that would give me 1/9. Now, the way I would find, using this is pretty much the scale factor for the area. So if I say the original, so the pre-image figure has an area of 60, find the new area using this new factor we found. So we would essentially cross-multiply, and I would get a new area of 540 inches squared. Thanks for watching.